In this example, we have two equations, 7x plus 3y equals 16 and 2x plus 9y equal 29. So we'll try to make one of the equations so similar in value, one of the variables similar in value, so they can cancel each other out. So in this scenario, we can multiply the 7x plus 3y equals 16. We can multiply it by 3, so we can eliminate in the next phase the y. So that would give us 21x plus 3 by 3, that would give us 9y equal 16 multiplied by 3, that would give us 48. So now this is our equation 1. Now we will add, subtract these two equations from each other, so we would have 21x plus 9y equal 48 subtracted from 2x minus 9y take away 29. So that means the signs of all the second equation will change. So we would have minus 2x minus 9y minus 29. So that means 21 take away 2, that would give us 19x. The plus 9y and minus 9y, they will disappear. So we would have then 48 take away 29, that would also give us 19. So that would give us x equal 19 over 19, and that would give us 1. Would be the value of x, and we insert x into equation 1. So in this scenario, we would have 7 multiplied by 1 plus 3y equal 16. So that means we move the 7 to the other side, so that would give us 3y equal 16 minus 7. And then we would have 3y take away, so we'd have 9 on the other side, and we would have y equal 9 over 3, which would give us 3 as the final answer for y. We can also do the same if we sub the x into the second equation, and we should get the same value for. In this example, we have two equations with variables of x and y. We'll try to solve them simultaneously. So we can see we have 5x plus 2y equals 6, and we have 3x minus 10y equal 26. So we can see that if we multiply the first equation by 5, that can potentially eliminate y. So what we will start with here, we have 5x plus 2y equal 6. We will multiply it by 5. That would give us 25x plus 10y equal 6 multiplied by 5. That would give us 30. So that will be the new version of our equation 1. Now what we will do, we will try to have 25x plus 2y equal plus 10y, which is the new equation, equal 30, which is equation 1, and add it to the second equation, which is 3x minus 10y equal 26. So what we would have in this scenario, if they are added, we would have 25 and also plus 3x, that would give us 28x. The 10y and plus 10y and negative 10y, they will disappear, and we would also have 30 plus 26, that would give us 56. Now we will divide 56 over 28, and that would give us 2. So that would be the value of x. We insert x into equation 1, which is the original one. So that will be 5 multiplied by 2 plus 2y equal 6. So we'd have 10 plus 2y equal 6. So that would give us the 10 move to the other side. So that would give us 2y equal 6 minus 10. So we'd have minus 4 on the other side. So we'd have 2y equal minus 4, and y would be equal minus 4 over 2, and we would have minus 2 as the answer. In this example, we have two equations with variables of x and y, and we'll try to solve them simultaneously. We have 2x minus y equal 12, and 6x plus 2y equal 21. So we can see if we multiply the first equation, 2x minus y equal 12, by 2, that will help us eliminating y when we solve them simultaneously. So let's go through the steps first and see how that would work. So first, multiplying this equation by 2, that would give us 4x minus 2y equal 24. So this is the new version of equation 1. Now we'll try to add it to the second equation. We would have 4x minus 2y equal 24 plus to the second equation, which is 6x plus 2y equal 21. Now 4x and 6x, that will give us 10x minus 2y and plus 2y, they will disappear, they cancel each other. We will have on the other side 24 plus 21, and that would give us 45. So we would have x equal 45 divided by 10. So that would give us 4.5 as the answer for value x. Now what we will do here, we insert to find the value of y, we insert x into the original equation 1, which is the 2x minus y equal 12. So we will do 2 multiplied by 4.5, take away y equal 12. So what we would have here, 4.5, 2 multiplied by 4.5, that would give us 9 minus y equal 12. So now we move the y to the one side and we move the minus 12 to the other side. So that would give us y equal minus 3. This will be our final answer. In this example, we have two equations in the form of x and y variables, and we'll try to solve them simultaneously. We can see that we have 3x minus 2y equal minus 6, and we have 6x plus 3y equal 2. Now what we can do here, multiplying the first equation by 2, so that will help us eliminating the y. So let's start with the first step here. So 3x minus 2y multiplied by minus 6. If we multiply it by 2, the equation, we can convert equation 1 into a different equation 1. So that will give us 6x minus 4y equal minus 12, and this will be our new equation 1. Now what we will do, we will try to add this equation 1 with equation 2. So that would give us 6x minus 4y equal minus 12, and we would have also 6x plus 3y equal 2. So now what we will do here, we will try to simplify the expression. So what we here, if we take away 6x from the second equation, so that means all the signs for the second equation will change. So what will happen here, that this 3y will also change, so it becomes negative 3y, and we'll have a negative 2 here too. So the 6x, take away 6x, will disappear. And we'd have negative 4y and negative 3y, that would give us negative 7y. And we have negative 12 and negative 2, that will give us negative 14. So now we have y equal minus 14 divided by minus 7. The signs will disappear. We have 14 divided by 7, and that would give us 2 for the value of y. Now the next step would be to sub the y value either into the original equation 1 or equation 2. So we say insert y into, say, equation 1. So that would give us 3x minus 2 multiplied by 2 equal minus 6. So that would give us minus 3x minus 4 equal minus 6. So we have 3x equal, with the minus 4 will move to the other side. It becomes minus 6 plus 4, so that will give us minus 2. Now we just divide x over 3, so x equal minus 2 over 3, and this will be the value for x. In this example, we have two equations in the form of x and y variables, and we can solve them simultaneously. So we can try to rearrange them in a form that we can work with. What we can see here, ideally you can see that the x and y, they are not aligned, so ideally it would be preferable to rearrange them first and then try to solve. So preferable to write this in the form of 3 plus 8y equals 33, and we keep the 6x here, and we move the 5y to the other side. That will give us minus 5y equal 3 will remain where it is. So now what we can see here, ideally it would be preferable to work with the first equation. So if we multiply it by 2, that will give us 6x, and then potentially the 6x will disappear. So let's look at that. So if we have the first equation changed, so 3x plus 8y equals 33 multiplied by 2, that would give us 6x plus 16y equal 66. So this is the new equation 1 that we. So now what we try to do, we will try to take away this equation from the second equation. So we'd have 6x plus 16y equal 66 over minus 5y equal 3. If we take these equations from each other, that means the sign of the second one will change, and this will become positive, and also this will become negative. So what we would have here, this 6x will disappear with this one, and we would have 16 plus 5, that would give us 21y, and we would have 66 take away 3, that would give us 63. So now we divide 63 by 21, so we have 63 over 21, and that would give us 3 as the answer for y. Now we'll try to insert, so we have the value of y, we try to insert it into either the original equation 1 or equation 2, or ideally preferable to the rewritten equation 2. So insert y into equation 1, so that would give us 3x plus 8 multiplied by 3 equal 33. So we'd have 3x plus 24 equal 33. Then we would have 3x equal. So if you take away 24 from 33, that would give us 6. So we have x equal 6 divided by 3, which is equivalent to 3. So in this scenario, 33 take away 6, that should give us 9. 9 over 3, that should give us 3 in terms of the final answer for value x.